Today we are going to look at the basics of coding, and we are going to start coding. Programming. For you to start programming, you need to have some basics, and today we are going to look at basics. We are going to look at how to install. You need language. For you to code, you need first to identify a language that you want to use. There are so many languages. There is, for me, most of the time you have seen in these live sessions, I usually use Java, but you can use Python. You can use so many other languages, and most of the languages have quite a stuff in common. It's only that they are different in how they are written. And so today we are going to look at what are functions. We are going to look at what are let's see, what are variables. You need variables, you need functions, you need variables, you need function, you need classes, you need what is called objects. But more so today, I want to emphasize on data types. What data types are? We'll be learning data types in different languages. No, I'm typing the wrong thing. Data types. If you check data types in Java, you see the list of 4 data types we have. You can check data types in Python. Data types in every language has data types. And for example, if you check what we have here on the screen, we have a data type. Then we have what we call primitive data types in Java. We call them, they start always with a lowercase, like an integer that starts with a lowercase. We have non-primitive ones that are uppercase. We'll be talking about this in shortly. We'll be talking about functions. We'll be looking at classes. We'll be looking at different why we have different languages, but we won't focus on the specs of the basics of a single language. So today I'm going to look at let's start. How do you start coding? The first thing you need to start, you need a computer, and you need a computer with good random access memory. Since when you are programming, variables will be stored in memory, which is basically your random access memory and what you call cache. So you need a good memory, cache memory. Most computers nowadays, they have like 3 MB of cache memory, and it's called L3. You can check L3 cache. This level 3 is inbuilt in the CPU. If you buy Core i3, Core i5, most of them, they have 3 MBs, some 6. You can, that's pretty good. You can have RAM. I would recommend 4 GB and above. 2 GB most of the time is not all that. Get a RAM of 4 GB and above. It will be good for programming. On my machine, I'm using 8 GB. So you can see you need a bit of higher memory. For hard disk, that's not quite important, provided it can store your stuff. A hard disk is not that important, but it might be important, but not all that. So today we are going to look at programming. What you do first, let's say we want to start with coding. Since I have Java on my machine, let me say what you need. For Java, if you want to program in Java, you need what we call JDK, in the version you want. We have JDK for every version. We have JDK 7, 8, and 9, 10, 11, 12, 13, and 14 is coming out in near future, which is 2 months from now, 2 months and 6 days from now, it will be out. So JDK, you need a JDK. How to get a JDK? You go to the site. The Java language has a custodian, which is they are known as Oracle, the same people who make the database. Then when you come here, you have to accept the license. After this for Java 8 update 21, we don't need that since it has Java 8 had a long-term license, and we need Java 11. That's the long-term one, and the one I'm using here. So you come here and you specify Java 11 development kit. So you get your Java 11. You specify on your machine. One thing to note when you're downloading JDK or any other development tool, you need to know the bitstream. Bitstream is what we say 64 bits or 32. If you download like this one here, you see it's written 64. This for Linux, and this is for all this for Linux and Mac OS 64. This 64 means is the bit stream, and if it detected a 32-bit stream, it would be written x86. Note that it's not written 32, it's written x86. That was the if you check here, it says usually refer x86 for 32-bit OS. If your operating system is 32-bit, you go to you download a 32-bit. If it's 64, you can download a 32 or 64, but I would recommend 64-bit. So how do you get to know? I'm not using a Windows, but if you are using Windows, there is a window button on your keyboard, and there is R, like window button. You get the window button, and then R. This is the command, how to go about it, to know the specification of your machine. Yeah, here it is. So when you click this, it means Windows run. The Windows button, it's on your left. I think on my keyboard, it's a third button. Then you click R, that means run. Then when it will pop up something like this. So here you come and type dx. Let me show you what it means. dx. This one. It's something with diagnostics of the machine. So when it gets you, it's not giving you the image, a clear image on what I want to show. The images, I'm looking the one with the highest resolution. Let me see this, but it's not displaying. Okay, it will bring out something that looks like this when you enter dx. Then It shows you something with to show you the memory the machine has. It will show you the BIOS. BIOS is the reserve system. It will show you the processor speed. Everything about the system will be shown here. So if you're on Windows, that's how to go about it. And if you're on Linux, I pretty know you know how to go about it. So I'll go straight to, you get your let's say I need JDK, this for Debian, this for different, this just for normal Linux. That's if you're using Linux. If you on Windows, you choose the one you want. So for you to download, you need to have signed up for an account with Oracle. This specific for Java. For other languages, it's quite easy. You just download and the languages come to your system. So here it's downloading. After that, you need to add it to your class path. The class path, you can check adding Java to class path. You can just Google adding Java to path on Windows. Whatever you add it, it's just a few commands on what you call command prompt on Windows. After you add that, now you are good to go. You can come here and actually say Java, then I think it's Java Java version. Yeah. If you check here, my machine has what we call OpenJDK 11, I think update, whatever it was released in 2019, 16th of April. That's it's a 64-bit. These are just what Java I'm using. So you need that to be on your machine. For others like Python, you just go to Python and get it on your machine. It's I think it's one of the easiest. You just download Python, the language, and you get it on your machine. You can Scala is the same. Scala requires JDK because it runs on the top of Java virtual machine. So I think it's for Linux, it's APT. APT is the package manager for Linux. You just say APT get install. Then you say Scala, and you need to be if you need to be a super user on your system to do that. So I'll just do that. And it to like now I'm installing Scala. You need to do that to pull Scala from the internet to your machine, then install it. That's how it's easy for Linux because it's just one command and it's installed. That's how you install. You can check on how installing other languages. You can install almost any language. PHP is the same. It's easy. So after installing, as I said, you need to install what we call an editor. Let me show you because this is the most used editor, VS Code. VS Code is by Microsoft. It's Visual Studio Code, and it's the most used. Most people use this. Although I don't, you can get it for your machine. For example, for my kind of system, it's a different kind of Linux. It's called Debian. So I'll download this and this. It will detect your. I think this site detects your machine, your OS, then gives you the options. But you can have for Mac, for Windows 64, Linux 64. You can all these. You can have them. You install it on your machine. Then this where you'll be writing your code. Then you'll be asked to to connect your editor with your language. For me here, I'm using IntelliJ. IntelliJ is by JetBrains. If you're on Java, I would recommend you to use IntelliJ. It's easy, it's professional, it's there are some stuff it does for you automatically. There are two versions. If you are starting off, you can get this one for free, the community version. It has you can code in Java, Kotlin, and all these other languages. It supports. I will be talking shortly about build systems. It supports versioning. We'll be talking about versioning, I think, in one of the System Fridays. We'll be talking about Git. Versioning is the most popular, and it supports most of this stuff. It's only that when you come to doing some professional stuff like doing Spring, Micronaut, and Helidon, these Swagger APIs, JavaScript, TypeScript, this you won't be able to do with the community version. So you have to pay for a license. On my machine, I'm using the Ultimate. Ultimate is the one for professional work. So you have to pay. What next? After you have installed, you come here. This is what you see when you first come. You run your if you're using IntelliJ, this is what you see. I'm using IntelliJ 2019-3, and so I'll come here and say create a project, and we start. And since I have so many choices here, I just want to create a basic Java project. If you check here, it says this is a version of the Java virtual machine that I'm using, the JDK we downloaded, version 4, version 11. Actually, it's not exactly the one we have on my machine because that was 3, this is 4. So if you want a different one, you just come here and choose where you downloaded it to. So if we go to where we had ours, we downloaded it to, I think it's in downloads, then JDK. I'm not seeing it, but that's how you choose. You just come choose the one and then you add. So let's go. You have to choose this. All these are different use cases, but we are not using them. You can use IntelliJ from so many languages: Kotlin, Scala, Groovy. I added an Elixir plugin. You can do all this stuff. You don't need that for now. You just need to choose Java. Then you go and hit next. You give your project a name, what you are doing. Let's say basics, because we are doing basics today. Yeah, and here we are. This is how it looks like. It will give you a project structure. This is how your project looks like. It will have your JDK. JDK is a collection of the standard Java libraries. If you check here, we have Java base, Java compiler, whatever, Java desktop, everything here Java. It comes with the JDK, and yeah, you have it now, and we need to close that. So if you want to start coding, you just come here and we say new. Then we choose Java. If you want to use Kotlin, you can choose their file or class, whatever you want. Then you come here. It prompts you with what do you want to write for Java. Your code, we say Java is object-oriented, so strongly object-oriented. We'll be talking about what object-oriented means, but for now, we just write, we have what we call classes, we have interfaces, we have enums. Enums is just enumerations. We have annotation, we have effects, but for now, let's do a class. We give it a name. Let's say first, let's say what? Let's call it basics. For lack of good words, let's call it basics. So we have a class. A class is quite important in Java. It's like the basic thing, the basic structure of what you are doing. And you check always a class will have not always, but most of the time you have what you call a scope. A scope is the package that is in here. And maybe I would have started by writing a package. Let me create a new package and call it first basics. Okay, it will get mixed up if you call everything basics. Let's say backend, just for backend Wednesday. And we come here and we create a new class, a Java class, and we call it basics. So let me erase this. That is it. So we have basics in package backend, and so this will be accessible to anything that's in here, the source. That's why it's public. This is called a scope. A scope, we have different scopes. We can have this as private. We can have as private. It's an error because you can't have a scope private when it's the name of the class here. And Java files always end with .java. So what I'll do, I'll just go back to how it was public. But if you want to another class here, we can say private, and then we say class learn. Then okay, we'll talk about this. So this class, we don't have to give it a scope. So classes in Java, they always start with capital letter. It's a convention. If you call it by a lowercase, nothing will happen. But classes always start with capital letter. It's a convention. So that is it. We have class basics and class learn. So the class does what we call, like I said, a class is, in the other time I said class is a blueprint of what an object is. So let's say if you are creating an object, I'll be talking what objects are. Would be write basics, then we say we give it a name like BS, then we will say new basics, then to have that. So this is how we create objects. We say it's of type basics. These classes are they're like blueprints for types, and when we want to define our types, it's basics. We have the name, and then we instantiate. So this we say these are blueprint for our objects. So a class, we say there are three scope. Let me show. A class can have a scope, a variable can have a scope, and function do have scopes. In this session, you'll be hearing me refer functions and methods as one thing. There's a bit of difference, and this is a bit different when you learn a language like Python. Functions are anything that's outside the class, and methods are inside the class. But Java, you can't write a function outside the class or interface. It has to be inside something. This is what we call encapsulation. Encapsulation, I'll be talking the 4 basics of object-oriented programming. Everything has to be inside something. It has like to be inside. Encapsulation sounds like capsules, inside the capsules, inside encapsulated. So we have what we call variables. If we say private int age, okay, maybe I can change this. Let me just call this for easy understanding. Let me call it a person. Do refactor, then rename. Let me call this person. Where a person, let's say a human being, a person, has what we call age. You always start with the scope, then the data type. We'll be talking data types. We say they are integers. A human being, you have your age as an integer. Integers are whole numbers, like 1, 2, 3. They are not like fractions, what you call rational numbers. Integers, they are whole numbers. So we'll be talking about integers. This is a variable. It is stored in the memory. Variables are stored in the memory of the memory. We said we need RAM. We need a L3 cache. And yeah, so you can have as many as you want. This will say what attributes are the person. Let me say this, when we are talking about objects and classes, think of them as nouns. Nouns or names of a person, names of something, and it's just proper nouns. I'm going back deeper to English, not just proper nouns, but you can have abstract nouns. You can check what abstract nouns are. So it's the name of things, stuff, mostly. That's what objects are. And a person has let's say string, gender. You start with the type. Someone is either male or female, and yeah. And one of the things we need to do, we need to every class, because when constructing, we need something called getters and setters. We'll be talking of them in the next few minutes. So let me first talk about data types. Here I've said we have integer, which is int. We have a string, and you check this one starts with capital and uppercase, and this starts with lowercase. And you can have, let me show all of them. Boolean. Boolean. What Boolean is either true or false. Like, are they married or are they not married? Status. If someone is married, that's true. If they are not married, that's false. You can have private. What else? We have integers, we have strings, we have Boolean, we have double. For double, this like a rational number, it has decimal points. Let's say we used to say in mathematics, it has decimal points. Let's say what number, let's say the amount in your account. Let's say amount, it can have some stuff, it can have decimal points, like you can have 20 shillings and 50 cents. So that's double. These are called data types. We said this is scope. This is scope for this what we call variables. So this scope says, private says it's just to be used inside the class or by the object. When it's created by the object, it's private. and these are data types. So let's get a look at the data types. We had them here. Data types, if you check quite what we did here, we had data types that had a lowercase, and like this one, string, that has an uppercase, and you need to note them. The one that those that have lowercase are called primitives, and those that have uppercase are called non-primitives. In other languages like Scala, they're called referential. And actually, most languages, even Java, there is a project, I think it's called Project, is it Panama? Not Panama, Project Amber also, that it's supposed to make everything start with capital, like integer, it will start with capital. And there's difference in that in memory usage and everything. So we'll be seeing that in the future. We would have lowercase integer with a lowercase. Like in Scala, we don't have any of lowercase. It's integer. It starts with a capital I integer. So we have data types. This is a kind of data we have. The way any data you have has a type. And so there are primitive ones and non-primitive ones. For primitives, we have Boolean, which said it's yes or no, true or false. Anything that has like it's binary, either true, false. It's that's a Boolean. We have characters. It's lowercase. It starts with star. We have numerics. Numerics, there are characters and integrals. And also, as we said, we have integers. Integers can be bytes. These are very specific. Most of the time, you don't use bytes. They can be short, they can be int, they can be long. These ones you learn on your own, what long means, what short means, but I'll talk about integer on this point. You can have what we call floating points. Floating points are such as float. Float is it just has a lower, it's a 32-bit string number that has decimal, and a double is a 64-bit string. So the difference is the bit stream, and that's basically what the difference between double and float. If we were to write float here, we just come and say private, and then we say float, then we say what else has a decimal point. Let's see. I am let's say change. I don't know what amount. Something. I'm just making up something. So the difference between a double and a float is the bit stream. Most of the time you use a double, and rarely you use a float, because float has a lower bit stream. And so, yeah, from this table you can see we have Boolean. False is 1 bit. You have characters, you can see. We have short, int. You can check what this means. Boolean means Boolean is kind of interesting. The name it was discovered by George Boolean. George Bull. Let's see, George Bull or George Boolean. George. George. Boone. I think it was called George Boone. Something like that. Yes. Yeah, this is a guy who came up with this. It just states something is yes, true or false, something, anything that has binary is either this or that. Someone is male or female, someone is married or not. Such stuff that has binary, they are binary in nature. So we have a class, and we have strings. We have data types. You can check all the rest of the data types. So after a class, you need what we call functions. I'll just say functions or methods. I'll be using them interchangeably, but there are a bit of difference. The difference actually came in we didn't used to call functions in Java. We used to call them methods, but since now functions like they are mathematical functions, they have to return a value. For a method, it doesn't have to return a value. It can return a void. Void means it's nothing. It can return anything. It can return nothing. And for functions, they have to return a value. That's the major difference. So they have almost the same, we call them signatures. They start with, let me start with the scope. Everything starts with the scope, and then it has what we call return type, what we want to get, what data type we get from this function. So the data type, let's say we want to get integer. The data type will be an integer. We'll be getting an integer, and then we say get int, and then we do that, and you have to say return. Every method or function has a return, and then we want to return the integer, the age, not the age. I think we want to return age, and then we have this one. This, when you create a class, you have to have this get, what you call get and status, and you have public public. This will return a void because it sets and nothing, we get nothing out of it. This is a good example of a method. So let's say set int, and then it will get integer age, and then return whatever. I'll show you how to create them automatically. So these, what you are doing here, is called functions. Functions are a way of they are like verbs. It's what we want to do. What we want to do, we want to get, we want to set, we want to post. For example, when you post on Facebook, it gets the data. There's a function that does that, gets the data from your the wall, where you enter their data, and post the data to the Facebook database. And also, so you have these, we call them functions. And so you can have as many as you want. They can be specific, but one thing you have to note, most people don't get what this means and what this means. This, after you declare the scope of your function, you come and say what return type. Return type is the nature, the data type of what you expect from this function. If you expect an age to be an integer, you say it will be of type integer. If you expect this to return nothing, you say this of type void. If you expect to return true or false, like get status, it will be a true or false. You say here, it's called a return type. One of the things you note when you're doing Java and Scala and C#, C++, and languages like this, they have what you call type system. In other languages like these are called static typed programming languages, because you have to say the type when you're coding. for dynamic typed languages like let's say JavaScript and Python, Ruby, maybe you have to the types are inferred. They are created at runtime by the system itself, the machine, the virtual machine of the language. So for these getters and setters, every class should have getter and setters. So for our editor here, we call them IDE, or Integrated Development Environment. It's just an editor with added stuff. So we need to come here. Since this is common to you do it every time, you don't need to write them. So I'll come here and say generate, and then say getters and setters for every of these, or every of these. So let me get this at the top so we can see where we were. They were here. So now we have generated getters and setters. You have here the getters and setters are just methods or functions that get and set. You see them when we, let's say, we create an object. Let's say we have an object person. Let's call him learner, and then we create an object of person, and then person, not person. So when we come here, you can say learner, and then you get this because it's not inside we are creating outside the class. That's why it won't show us. You can call any of these get or set, whatever. So this mostly how a class will look like. If you check getters, they don't have any parameters. These are called parameters. They don't have any parameters. But setters, they always have a parameter. Getters, they return something. They have a return type. For setters, they don't. If you check here, it's just sets and nothing. We get nothing back. For like gender, we return gender. For setting, we just set and we get a void. Void means we don't get anything. Boolean is status. I'd say the status. Okay, yeah, that's how booleans are. Set, it does the same thing. So this is the basic of what we use for coding. This is called a class. A class is, I said, is a blueprint of an object. So we have a class. In static type languages such as Java and Scala and quite a number of others, we have what we call an interface. And let's say interface human beings. Interface human beings. Interfaces, for the longest time, they always have abstract methods. They don't have, let me see what the difference between abstract and concrete methods. Let's say, you see here, we have this. So this actually does something. If you have an abstract one, let's say human beings, what do human beings, let's say, eat? They have private, eat, they do eat. What data type is that? Okay, what do they, no, not it. Let's say, read. Let's say it's a Boolean. You either read or you are reading or you are not. So let's say read, and then we get that. There it says there's an error, and a method body, return false. Okay, this is not what I wanted to do. Private integer get, okay, private integer get amount, and amount is kind of, let's say, an int of amount. If you see this, I'll be there's a totally different things why it's behaving this way. If you see any red thing, there's a mistake somewhere happening. And if you come here, you just know what is expected. It's expected to do that. So this is a method in an interface. So interface contain abstract methods, but nowadays they can contain what we call concrete methods. If an interface, if you see a function starting with default, that's a concrete method. Concrete method is from Java 8, coming Java 8, Java 9, Java 10, 11, nowadays. If you have concrete methods, we call this a functional interface, and actually it's annotated with functional interface like this to say this contains, they contain concrete methods. So that's an interface. You have, for an interface nowadays, it has to have one abstract method. One abstract method, it can have concrete, but it has to have one abstract method. They are what we call abstract classes. And it's a class. Abstract, let's say people. Classes have to start, classes interfaces have to start with a capital people. And we can declare this abstract. If you declare a class abstract, means every function, everything in this to be abstract. It won't have an implementation. We'll be doing implementation somewhere different. So today we have been looking at data types, how to represent different data. We want to make sense of data. We want to model how the person we want to model how the attributes of a person, what the person does, and then so this is the basics. You need data types. You need variables. You need you need these functions. Get all the functions. What else do we need? We need to have, for you to run code in Java or in any other language, you need to have a main, let's say, class. Let's call it our main class. Our main class. You need to have a main class, a class that has main method. It can be here or anywhere you want. So main method returns void. We say it's a public. I'll be talking about static void main. And if you check methods, functions, they start with lowercase. It's a convention. You can start with uppercase, but as a convention, they need to start with lowercase. So we have this, and it needs to have string, and then that, And this how it looks. This is the main method, and you check here. You can run this if you want to run anything here. So if you let's create an object of type person inside here. You just come and say person. This is the type of the object we are creating. Then we say what we call them. Let's say done if it's key, and then this is arbitrary. You can call it whatever you want, the person you want. Then you use keyword new for creating an object, and you say person. And yeah, now we have a person object. This person object, we can say done dot. Now you see, if you want to get the age of Dan, that's how you get it. If you want to set the age of Dan, you get the age of Dan, it returns an integer. Like let's say how old is Dan? How old is Dan? I think it's 99 or 200 years. And my last birthday was 200. So you say, if you want to set that age, let's say you need the age in an account. Say set age. Then you give the age. Let's say it's 1 or 99, whatever. So this we are creating objects. This creation of objects. I'll just use one big word. It's called instantiation. We are creating an instance. I think yes, instantiation. So we are creating an instance of a class, which is an object. So I won't go much deeper from here. I'll just say, when you say something is static, static means it's a class. You can't use it outside here. I'll be explaining the difference between a scope and saying something is static in our next session. So this is the basics of programming. This is the basics of Java. And yeah, a recap. We talked about data types. We talked about classes. We talked about interfaces, abstract classes. We talked about what else? Functions or methods. Yeah, this is the basics. If you get to know this, you are good to go. And we said how to install. You install, you get, let me see, I installed, we were live here. I installed Scala on my machine, and I can come and say a Scala, and to start an interface here. I would have cleared this. Let me do away with this terminal and start another one here, and say Scala. And so it will give me a terminal, and I can say use it first. Start with using a language like a calculator, like 1 + 1 you get is an integer. This is what I was saying. These integers are capital in Scala, so you get 2. Let's say 2 multiplied by 3. You get is an integer of 6, or if you do 5.0 minus 3.4, you get this a double of 1.6. Now you see the sense behind data types. This data type here, you see the data type being written. The result 2 is a data type of that, and you can do this. What I'm doing here, you check. Java actually has this. It came not long ago. It's called a REPL. Python has. Almost every language. Ruby has one. Most languages nowadays they are called repo. Repo is written like this. Repo. Read, evaluate, print, and loop. That's what it means. Let me see why it's written. Read, eval means evaluate, and then print and loop. This you see it if I CLI or anything. It's like you write your commands. You don't have to write the whole objects. You just write what you want, and it gives a result immediately. So this is quite helpful when you are learning a language the first time. If you check Python, most people like it because of this. Python actually it is giving me the repo. When you install Python, it will give you a repo, and then you can type on your machine. So those are the basics we wanted to cover today. We'll be doing more on this. We'll be explaining deeper on how to do controls. Last time I talked about, it was a bit advanced, but we'll be talking about that. We'll be talking about how to do, we'll be talking about, I think next Wednesday, we talk about collections. Collections are like lists. Let's say list of person. Now we use our class as a type. Let's say we want to import this and do this, and then person, and then we say these are people, and we say arrays. We want to array people dot as lists, and then we give them the attributes. We had an integer. What this now? This integer, gender, status, amount. We come and say a person has that. Then we give them a list. Then we work with this. So we'll be talking about collections. We'll be talking about collections in Java, collections in Scala, and collections in, let's see, collections. Let's go to collections in Java. Yes, we'll be talking about this. We'll be learning what iterables are, collection, list, queue, sets, array lists, linked list, vector, stack, sorted, tree set. I'll talk about the most used. We have a list, we have sets, we have queues. Priority queues are used sometimes. Hash, we talk about hash map and hash set. We talk about, I think, the vector, I think of that. Array list, which is like an array with some stuff that looks more like a list. We'll be talking about this collection API, and you can check collections. The highest one here is iterable. Other languages like Scala, the highest one, if you check collections in Scala, the highest is called traversable images. The highest one is traversable because it treats its collection a bit different from Java. It treats its collections as a graph, and graph you traverse through graph. So you can see here we have a traversable, we have iterable, we have sets, we have maps, all the sets. So we'll be talking about this. This collection is like you have a list of stuff. You have an array. An array is like you have several stuff that have a size that is fixed. let's say you have 5 people, you get their names. They are basically different stuff. We'll be talking about them next time. You can check collections API, but an action point for today is get the language you like most. The language you like most, it might be, let's say, which language do you, let's say, if you are, let me give a way forward. If you are doing most of big systems, go for Java. If you are doing more of data science, you are doing more of analytics, go for Python. If you are doing, actually, if you are Scala, it's a bit, it has quite a steep learning slope. That's why I would recommend it, but it take more time than you would when you are doing Python. Python is easy. You start with it today. In a week's time, you know exactly what you are doing. Let's say you dedicate 2 hours a day for learning. You, in 1 week, you completely have known what you are doing. Get one programming language, get it installed on your machine, and install, let's say, if you let's say you choose Python, make sure you Python, you get Python on your machine, install it, and then actually, when you come to Python, you have to don't use two. There's a difference. Last year, Python said it's going to be supporting 2, so you have to use Python 3, and currently I think it's Python 3.7. So make sure you use Python 3, and yeah, we'll be looking at the way Python does. Like, for example, here they have written a collection which is an array, and then this a function print, and then prints this. Will be, I think, sometime I'll install Python editor, then we do some Python. So you get Python on your machine. Then the next thing you need to do, get an editor. I've used this quite a number of times. It's called PyCharm. It looks almost the same as IntelliJ. It's by the same company, and yeah, you download it. You have to, I think there are 2 of them, professional one, and yes, there's professional and community. If you want community one to start with, it's so good. It's almost like IntelliJ for Python, and use it to create. It has a repo. It has everything we talked about today. The language, you install it. So that's Python. If you choose PHP, there's a bit. Let me see. There's when you are learning programming, I will use Java, Python, and PHP to explain 3 different things. Java is a static typed compiled language. Compiled means you need to compile your code. That's why we need a build system. We'll be talking about build system like Maven, Gradle. We'll be talking about that in the future. And for Python, it's a dynamic typed compiled, interpreted language. There is what you call interpreter, and this means actually when you are running Python code is a bit slower than when you are running Java code. Java has what you call JIT compilers, just in time compilers. So every time your code you compile it gets compiled instantly. For Python, it has to be interpreted. That makes I'll be explaining what compiling and interpretation means. That makes Python a bit slower than Java. For PHP, it's a quite a different language. It's not compiled, it's not interpreted. You just run, it's just write a code and run. And it's not, if we say it's not compiled, I'll be explaining exactly what it means. It's a general purpose scripting language that's specific. All these languages they are multi-purpose. You can use it for web. Mostly if you use Python, you can use Django framework for web. You can use Django. There is Flask. Flask framework. There's what? Okay, I don't remember the others. If you use PHP, you have Laravel, and you have PHP. What do you call Coordinator? We have Yi2. For Java, we have many. We have Micronaut, we have Heridon, we have Spring, we have quite a number of them. For Scala, you have Play framework, you have Lift, and also for, I won't be talking about that, what you call CQRX, and we have what you call Lagom. So that's many. You can do web. You can do what you call embedded systems, like systems on cars and system on those stuff. They're called embedded. You can do embedded. You can do cards. Cards are like ATM cards, SIM cards. That one is actually purely Java. I have not seen any Python code for that. You can do their general purpose languages. I said if you want to get up very fast, you learn Python. If you want to get what programming is all about, and most of what programming is use Python. Use Java. Java gives you a wholesome way of understanding static type languages, how they think, then if you do Scala is a bit high end. Scala meets you at the point where you are. You can do it. You can use it as a starter. You can use as you are starting. You can use it for high end stuff that actually is quite good for what do you call data science. It's quite good. For example, Netflix uses it for data science. We can Twitter uses it for data science. LinkedIn uses Scala for data science. Quite a number of others, because it's not like Python. When you need static typed language for data science, you know for sure R is not static typed, and Python is not static typed. So you go for Scala, and sometimes you don't need static typed languages when you are doing data science. Let's say you are running machine learning algorithm. You don't need it to fail just because you have not specified the type. So you want to be specific. That's why for that specific reason, you would go for Python instead of Scala. So today we looked at different stuff. We talked about classes. Classes are blueprints for objects. Classes, you think of them as nouns. They start with capital letter. Okay, uppercase. We say uppercase, and we have these data types. We talked about integers, strings. Strings is anything. Strings is like a name of a person. And if you want to identify strings in coding, every time you see that, you see, I don't remember, double what? Okay, they mean string. They mean that's the string. And A Boolean is either you say is true, anything that returns true or false. A double is anything that has a decimal, let me say, use decimal point, because that's how we are taught, but decimal means something quite different when you talk about it here. Like it's 16 point something, something like that. So I'll recommend you the same way. I said you download a language, whether you choose any of your languages, then you install an editor, and for starting up, I don't recommend the stuff. I don't recommend because they will give you a hard time. Stuff like Atom, editors like Atom, they are free, but for starting up, no, don't use them for starting up. Sublime, they are free. Sublime, they will give you it's what you want to focus on, programming, not other stuff. So for Atom, don't use it now. You can use it when you become professional. For Sublime, use it when you become professional, because you have to do a lot of adding stuff. So that is it for today. When we meet next time, have your language installed, have your editor installed, and yeah, and try to do a bit of coding. For on my side, I have downloaded Python, and I have downloaded PyCharm. So I will be doing both Java. I'll try to compare them, Java, Python, and Scala, all of them at the same time, so you can see different flavors, how different languages are presenting. Yeah, and that is it for today. Thanks for joining me. See you next time. Yeah, let me see. Johnson, thank you for joining. Kensoft, I see you. A data scientist, Penina Mutito. I know you know quite, you're good at Python and R. D, thanks for joining. Hepta DJs, thanks for joining. Kibet, Theophilus, thanks. Mash Peter, thanks for joining. And yeah, install those languages, and we meet next time. We continue learning programming. Programming is the most awesome thing you can do. It's the highest paying job in the world. It's quite good. There's so many good stuff about programming. And yeah, have a good night. See you next time.